So, welcome back student to the next class of complex analysis. In the last class we started very interesting thing which is series and sequence, and we mentioned that if we have a series something like that, n is equal to say 1 to infinity, which is z1 plus z2 plus z3 few complex number, then there is a way to test whether these things, these partial sum are going to some converging limit or not. And we mentioned that if say limit k tends to infinity, z k plus 1 z k, if this quantity is L, then this partial sum will going to converge if L is less than 1. It is converge if L is equal to L is greater than 1, then it will diverge, and if is L equal to 1, then there is no conclusion, inconclusive. There are another way, this is called the root test, this is called the ratio test. A similar kind of test is also available, as I mentioned, it is a root test, we call this root test. Sometime also we required that, where we need to find out this, and the condition over k is same. If k is less than 1, then it is convergent, if k is greater than 1, it is divergent, and if L is equal to 1, then we can't say anything about the convergence of this particular series that is written here. Okay, this was the last day's thing, so we will going to exploit this more. Before that, I need to give you some important thing which is called the power series. Normally a power series is represented in this way. This is the representation of a power series. Now, if a function fz is analytic in some region, then from Cauchy's integral formula we find that if a, that means the value of the function some point a can be evaluated as this. Not only that, I can also find the value of f n z, f n a, that means nth order derivative. Mind it, when I am writing this expression, f z is an analytic function. Now, I try to find out the nth order derivative of that particular function f z at that point a, and it was something like this. That means nth order derivative is possible for this analytic function, and keeping that in mind, we can say that a function, if it is analytic, we can somehow put this in some series which is in this form. Now, what is the beauty of this form? Let me now explicitly write this. So, you can have the nth order derivative of these things which is possible. So, first term is say a0, second term is a1 z minus z0, third term is a2 z minus z0 square, and so on. So, it is a polynomial with z minus z0. So, if a function fz is represented in this series, then we can say this is an analytic function and having nth order derivative, because if you make a derivative of this function, you will have this quantity, the right hand side you can have the derivative of that. So, that is why the power series is important, but also one thing is important here for this power series, you can't expand this series to according to your choice. So, there is something called circle of convergence. Circle of convergence. That means you can expand the function in terms of power series if this is the point z 0 and here I have z, and if my radius r. So, in this region you can expand, maybe it is possible to expand this particular series, so that the series is convergence. So, in order to have the convergence of this series, we should have something called the circle of convergence, and the point is that you can't take any z and expand in this series. There should be some restriction, and this restriction is coming through this r. So, mod of z minus z0 is less than r. This is your limit for which you can able to expand a function in power series. If this condition is not valid, then there is a possibility that even though you are expanding something, it may not converge. So, converging the series is an convergence of that series is an important criteria. So, in order to converge this series, you need to also find out what is the circle of convergence, and this r is called the radius of convergence. R is called the radius of convergence. This r, however, we can find out with this ratio test and whatever the test we are mentioned just before. So, let me do that. So, how to find out this circle of convergence or this radius of convergence for that particular series to be convergent? So, let me write this series say big Z in K. So, I am just write this thing as big Z K, where K is 0 to infinity as usual. Then my ratio test suggests limit K tends to infinity big Z K plus 1 divided by these things, say it is L, these things is L. So, now if I put these things is L, then I can have limit K tends to infinity. This quantity is nothing but a K plus 1 Z minus Z0 K plus 1 divided by this AK Z minus Z0 K, which I say it is L. Still Now I don't know whether it is less than 1 or greater than 1. Now I need to put, after that I need to put the condition. For the convergence, the condition is L has to be less than 1. That is my condition. So after that I can say limit k tends to infinity, this quantity a k plus 1 by a k multiplied by this quantity z minus z 0 is less than 1 for convergence. Now I put the condition for my convergence. So this is the condition of convergence. This quantity, just before I mention, is something called R. So let me erase this. So say limit k tends to infinity, I calculate this quantity a k plus 1 divided by a k, this quantity I say small l, this is small l. So from that, and also z minus z 0 is equal to R, since this is the region where I try to find out my expression. The expansion is convergence under the condition when z minus z 0 is R, and this R is the radius of convergence. So from that I can find that L multiplied by R is equal is less than 1, or I can say the radius, the limit of radius of convergence is something, the limit of radius of convergence is L R equal to 1 by L. This is the limit, because when it is equal to, when as far as it is less than 1, so it is convergence. So when it is equal to 1, it is that limit for which the things are convergence. So that means the radius of convergence is essentially 1 by L, when 1 by L is defined at this. So if I have a power series in my hand, so my first task is to find out what is the radius of, what is the circle of convergence. So the circle of convergence is defined by this radius R, and I can find out this radius R in terms of L, which is nothing but this limit. That is the thing. So first a series is given to me. So let me summarize once again. This is the series is given to me, and I am asked whether this series, say 0 to infinity, is convergence or not. In order to convergent this series, in order to converge, so what is the region where I can expand this series so that it will be a convergent series. So the region, in order to find the region, I need to find out this limit. When I find this limit, I will find L. So R is eventually 1 by L, which gives me the radius of convergence. So radius of convergence. Radius of convergence. So the radius of convergence can be figured out. So if the problem is given like this, and if you are asked to find out that what is the radius of convergence, I need to just calculate this. So now let us go to some examples, and then maybe things will be clear. Okay, so let's see what example I have today for you. Okay, so example 1. And the series that is given to us is z to the power k plus 1 divided by k. So this is an series power, I can put it as power series also. So 1 to infinity. this series is given to us. So, now if I expand this series, my first term will be say z square, my second term will be z cube by 2, my third term will be z to the power 4 by 3, and so on and so on. So, what is the radius of convergence of these things? I mean, what should be the value or the restriction over z for which this should be a converging series? We already know the result, but let me do that. So, if I write it in terms of this series, this is nothing but a power series where z0 is 0 and ak is 1 by k, this quantity. So, if I find limit k tends to infinity a k plus 1 by a k, which I call L, then this comes out to be L comes out to be limit k tends to infinity a k is 1 by k, a k plus 1 is just these things. So, k by k plus 1. If I take k common from both the sides and put the limit k tends to infinity, this k will cancel out. So, 1 divided by 1 plus k, which is 1. So, that means the L value is 1, or radius of convergence is 1 by L, which is 1. So, the radius of convergence is 1. So, what is the meaning of that? I can expand this function in this way. I can expand this function in this way for all the z's z0 point is 0. So, this is 0 and this is 1 unit radius, and this is my z plane x and y. So, all the z less than 1, whatever the z I put inside the circle should be less than 1, and for that less than 1 I can expand this series in this way, for which the radius of convergence is this. So, if I put this, if I take z outside, then whatever the value I have will not be convergence. Here whatever the z here should give you only the convergency, that means it will go to some value which converges. Okay. And radius of convergence is 1. Let us go to the next example. This was a very trivial example. So, okay, my next example is example 2. It suggests summation k 0 to infinity, and the function is given as z minus 2i whole to the power k divided by 1 minus 2i k plus 1. Okay. So, again we have a series, it is also equivalent to some power series. It is nothing but a power series where z0 if I compare this to this, we have 2i, and what about ak? Ak, if I compare, it should be 1 by 1 minus 2y, this quantity, right. So, a series is given to me and we need to find out the radius of convergence for this series. So, my goal is to find out the radius of convergence, and this series can be written in this particular form, ak z minus z0 to the power k, which is nothing but a power series, where z0 is that and ak is this quantity. So, now the rest part is quite mechanical. I need to again find out what is the value of this quantity, because this is my small l. So, small l is this quantity. Once I find small l, the r will be just 1 by l, small l, then I can find out the radius of convergence. So, if k tends to infinity, this I put. So, a k plus 1 will be 1 minus 2 I k plus 2, because a k is this plus 1. So, a k plus 1 will be 1 by this, and a k will be 1 by, I will have this. The limit is as usual, k tends to infinity. So, this term will be simply 1 divided by 1 minus 2i, mod of this quantity, mod of this quantity. So, the next part is to make it a plus iv form. So, limit k tends to infinity. So, the limit k tends to infinity is meaningless here, because the k is already gone. So, let me erase this and then need to find out what is the mod of these things. So, 1 minus plus 2i divided by 1 minus 2i 1 plus 2i, this quantity. So, that quantity we need to just find out, that will be our L. So, let me erase this part which we have completed. So, my L, this is L. So, L is mod of 1 plus 2i divided by a plus b into a minus b. It is a square minus b square. So, a square is 1, b square is 4. So, it will be 5, and mod of this quantity is 1 by 5 square plus 4 by 5 square whole to the power of half, or 5 by 25 whole to the power of half, or 1 by 5 or 1 by root over of 5. So, my L value is turns out to be 1 by root over 5. So, that means the radius of convergence R, the radius of convergence R will be 1 by L, that means root over of 5. So, this is my radius of convergence. Now, let us look what is the region. The region is important. You need to find out where is the what is the region where this power series is valid and it is converging. What is the region for which it is converging? So, this is z0 is 2i. So, this is say z0 point. Okay, let me put it here. This is say z0 point, which is 2i, and with 2i I need to make a circle. I need to make a circle here. with radius root over of 5. So, this is my circle of convergence and this is my radius of convergence, which is root over of 5 that I figure out. Whatever the z is here, if you all this z inside this circle, red circle, for that this series will be convergence, and if the z is outside, then this series will not going to converge. That is the thing we find. Okay, so quickly we will do another example before this class. Let us take what extra example we have. So quickly we will have one final example. Example 3 say. So the series that is given to us is k 1 to infinity minus 1 whole to the power k z minus 1 minus I whole to the power k divided by k 2 to the power k is something like this. So, a k z0 is nothing but 1 plus I, this is my z0, z minus z0, z0 is some point here which is this, and k ik is minus 1 to the power k divided by this 2 to the power k. A k plus 1 is minus 1 k plus 1 divided by k plus 1 into 2 to the power k plus 1. L is limit k tends to infinity a k plus 1, quite mechanical, but if you practice then it will be good. Limit k tends to infinity, this quantity first I need to write. So, minus 1 whole to the power of k plus 1 divided by k plus 1 2 to the power k into 2, and then a k is k 2 to the power k divided by minus 1 into k mod. So, since we are using mod, so I should not bother about this sign. This sign will be minus 1, 1 k and 1 k will cancel out, minus 1 will be remaining, but this minus sign, since I am taking the mod of that, we should not bother about that. So, it will go away, 2 to the power k, 2 to the power k will cancel out, and I will have limit k tends to infinity, this 2 half will come out and only I have k by k plus 1. Again if I take k common, then it will be 1 plus k, and then if I put k tends to infinity, it will be just 1. So, eventually I will have half. That means my r, which is 1 by L, is equal to 2. So, where should be the radius of convergence and how these things? So, radius of convergence is 2 I find. So, for which set of z values we have this series to be converge. So, 1 plus I point is somewhere here, this is 1 and this is I, this is the point, and if I take a radius circle of radius 2, where this is circle of radius 2, then these are the points, these are the z points, this is 0, x and y, all the points inside this circle. If I take this all z, then if I expand this, then it will be convergence. So, this is the test of convergence and find out the radius of circle. So, I believe today's class with this example you are now familiar about the fact that if a function is given to you which is a power series, then this power series will be convergence or not, and what should be the radius of convergence you can figure out from this treatment. So, with that I should stop my class here. So, in the next class we will start interesting thing which is the Taylor series, and in the Taylor's how a function can be expanded in terms of Taylor series we will going to find. So, with that note, see you in the next class. Thanks for your attention.